In year 12,000, the future archives keep the past in stranger forms than memory. Here, recovered objects do not merely survive, they argue. Their engravings wake, and lost eras speak again. Tonight, the vault opens around a burned solar control key, recovered from the debris halo of the final orbital command station. A relic from a human age so distant that even the old solar empire has become folklore. When the key's memory stirs, a voice from that era says, "We are not killing the star. We are closing the shutters." How do you switch off a star without extinguishing it? And why would anyone burn the key that made the sun disappear? The object is small enough to fit in one human hand. Layered tungsten ceramic, melted black along the grip. Gold conductor bands scorched almost flat. Its markings are blunt in the old language. Sole authority, prime array, omega access. And beneath them, one phrase that still troubles every cataloger in this vault, Veil Protocol. The first memory is not of an explosion or a war. It is of the sun itself, slowly divided by moving points until daylight becomes a managed permission. That is the claim sealed inside this key. Ancient humanity did not switch off the sun, it switched off access to it. The impossible question sounds theatrical at first. Who switched off the sun? But the science is less mystical and more unsettling. NASA's solar science is clear. The sun is a main sequence star. It shines because fusion in its core converts hydrogen into helium. No known human technology can simply reach into a star and halt that process. So, if a civilization ever spoke of switching off the sun, it could only mean something else. Not extinction, obscuration, not killing the furnace. Controlling who gets the light. That idea did not begin with megalomania. It began with climate fear. Long before anyone dreamed of hiding a whole star, researchers discussed a far smaller intervention. Could sunlight reaching Earth be reduced by a thin, artificial shield placed near the Sun-Earth L1 point? Peer-reviewed proposals explored exactly that. James Early described the concept in 1989. Roger Angel later imagined trillions of small spacecraft, each contributing a tiny fraction of shade. Important distinction. These were not plans to alter the sun. They were plans to intercept a sliver of its light before that light reached one world. And once a civilization learns to manage a sliver of sunlight, it has started learning the politics of managing all of it. The second memory in the key is quieter than the first, not crisis, committee. Engineers argue over whether the shades should remain temporary. Some want them dismantled once warming eases. Others see a larger pattern. If autonomous spacecraft can hold position, coordinate by the billions, and survive in intense solar environments, then the same industrial grammar could scale upward. A climate shield becomes an orbital utility. An orbital utility becomes a market. A market becomes a swarm. This is where established science gives way to disciplined speculation. Freeman Dyson's 1960 proposal was never a rigid shell. It was the idea that advanced civilizations might surround a star with vast numbers of orbiting collectors. Kardashev's scale later gave language to the ambition. A civilization approaching star-level energy use. The key's memories suggest humanity discovered something dangerous at that threshold. If you've enjoyed this story so far, subscribe to future archives. There's another mystery on the way. Here, the archive must separate theory from fantasy. A Dyson swarm is not forbidden by physics in the simple way a solid shell would be. Distributed collectors, habitats, mirrors, and radiators could orbit a star on many paths. In principle, a civilization with enormous industry could intercept some fraction of stellar output. But the phrase in principle hides the real difficulty. Materials, heat rejection, orbital stability, maintenance across millions or billions of independent objects, and above all, social coordination over centuries. The research community treats such structures seriously enough to search for technosignatures. Astronomers look for unusual dimming, strange transit patterns, or infrared waste heat that might betray large energy harvesting systems. That is established. What remains unproven is whether any society could build one without collapsing under the weight of its own logistics. The key remembers a civilization that said yes. The first path preserved in the archive is called, in modern terms, the climate ladder. Small shades solve a local problem. Then they solve a seasonal problem. Then an agricultural one. Then a migration crisis on another world. The memories show Earth's sky dimming by fractions at first. Then Mars using redirected light. Then rotating orbital lattices adjusting day length for habitats that no longer trust natural cycles. Nobody announces the birth of a stellar civilization. It arrives disguised as infrastructure. This path is speculative, but plausible in shape. One reversible intervention creates launch capacity, autonomous coordination, legal precedent, and an expectation that sunlight is governed. That may be the most radical step of all. Not building the first shade, but teaching generations that daylight itself can be negotiated. The second path is harsher. Not climate management, extraction. If cislunar industry matured, if asteroids were mined at scale, if Mercury itself became feedstock for solar industry, then a swarm would not be built as one project. It would emerge from profit, automation, and strategic competition. Millions of collectors become billions. Power is beamed, stored, traded, and rationed across the inner system. In that future, visible sunlight stops being sacred. It becomes inefficient. Worlds can live under manufactured dawns. Habitats can tune their own spectra. Whole populations may prefer filtered skies, lower radiation, and stable energy contracts to whatever the uncurated sun once provided. This too is speculative, but it follows a recognizable human habit. Once a resource can be optimized, someone eventually asks why it should remain wild. The key's third memory begins when that question is no longer philosophical, it is administrative. Now, the archive reaches the line between grand engineering and strategy. Could a civilization make its star seem dimmer without changing the star itself? Speculatively, yes. A sufficiently large swarm of shades, collectors, and radiators could reduce visible output along selected lines of sight. Not everywhere, not for every observer. But for chosen directions, the star could be masked, broken into anomalous transit signatures, or made to look less interesting than it truly was. Technosignature researchers already ask the mirror image of this question. If alien engineering existed, what would we detect? Dimming, infrared excess, strange transits, a missing balance between visible light and waste heat? The key proposes the inverse. If you knew how astronomers search, you might know how to disappear. And once that idea exists, every collector becomes two machines at once, a power plant and a shutter. The fourth memory is the most human, not machines, arguments. One faction insists the sun must remain visible, not because visibility is efficient, but because continuity matters. Their case is almost religious. The human story began under open daylight. To hide the sun is to mutilate civilization's oldest clock. Another faction answers with cold arithmetic. Symbols do not protect species. If light reveals location, then sentiment is a luxury. The archive records panic on worlds assigned to permanent artificial twilight. Some citizens celebrate lower heat, safer habitats, and insulation from solar storms. Others call it vandalism on a civilizational scale. Children draw pictures of a sun they are told still exists, just elsewhere behind machinery. This is the consequence viewers often miss. A star is not only an energy source, it is law, ritual, agriculture, architecture, sleep, migration, memory. To govern sunlight is to govern nearly everything at once. Then the key reaches the command station. Operators sit in high solar orbit, watching three numbers rise together: swarm density, infrared leakage, and what the memory calls a detection envelope from deep interstellar space. Here, the archive must be honest. There is no established evidence that hostile intelligences watch active stars for prey. That belongs to speculation, not science. But speculation can still organize empires. The station authorizes Veil Protocol. Collectors pivot, shades migrate, radiators disperse. The swarm stops behaving like an energy network and starts behaving like camouflage. For selected observers beyond the system, the sun fades behind machine-made darkness, while inner system habitats survive on stored energy, redirected illumination, and tightly rationed heat budgets. From below, people say the sun has been switched off. From above, the operators know a more exact phrase: the system has made itself difficult to see. And yet one memory fragment refuses to align cleanly: a descent file. It asks whether the Watcher is real at all. This is the archive's darkest branch of speculation. Perhaps the threat was genuine. Perhaps a civilization studying technosignatures discovered that bright, energy-rich systems disappear too often to ignore. But perhaps the data were noise, ideology, or manipulation by leaders who needed a permanent emergency. The difference matters, because the same infrastructure that can hide a star can also centralize authority beyond anything old democracies ever imagined. Whoever controls the shutters controls climate, power, agriculture, observation, and the psychological horizon of entire populations. If the danger was misread, then the hidden sun was not a shield. It was history's largest act of fear. The key carries no verdict, only burn damage and urgency. The final minutes preserved in the artifact are physical. Remote systems fail first, then sabotage, or overload, or both. The station takes heat beyond its design margin. Automated command channels collapse. A human operator reaches for the physical key because software trust has died. The shaft enters the console. Authentication begins. The memory fractures under radiation, but one detail remains: tiny human initials etched near the grip, almost erased by heat. That matters. Not because it tells us who they were, because it reminds us what the key truly is. Not a symbol of omnipotence. A last resort manual override in a civilization that no longer trusted its own machines, its own data, or perhaps its own motives. Someone forced the handshake anyway. So, the twist is not that humanity learned to kill a star. It did not. The twist is stranger. This key first appears to belong to a climate control grid, or to an energy empire finally mastering its home system. But the deeper reveal is that it authenticated camouflage. Ancient humanity did not darken the sun to master nature. It darkened the sun to erase its own visibility from the cosmos. That single sentence changes the artifact completely. The burned key is not proof of triumph. It is evidence that a star-harnessing civilization may decide that abundance is less important than silence. And if that is true, then the brightest phase of a species may also be the moment it becomes most afraid of being seen. The future archives cannot tell us whether the Watcher existed. They can only tell us that the fear did. And perhaps that is enough to make this relic dangerous. Because the road toward a hidden sun does not begin with paranoia at the end. It begins much earlier, with useful shades, practical automation, justified emergency powers, and a culture that slowly accepts that sunlight is a system to be managed. By the time the final key is burned, the decision may already be centuries old. So the artifact leaves us with an argument, not an answer. If humanity could hide the solar system by dimming or masking the sun, would that be a necessary act of survival, or an unforgivable decision made on fear without proof of a Watcher?